Welcome to Spring LIB.
Hi there. Um, Here we have to find the forces of interaction between the charges. Unfortunately, the task was incomplete, so I had to presume that the charges are shown in microcoulombs and that the third charge is negative, while charge 1 and charge 2 are positive. But nevertheless, let's try to solve this problem. First of all, we'll need to find a force with which Q1 is interacting with the electric field created by Q2 and Q3. So Q1 and Q2 carry the same charges. That's why they will undergo repulsion. And Q and F21, the force of interaction between charges 2 and 1, will be directed to the left and will be negative. Meanwhile, F31, the interaction between charge 1 and charge 3, will be positive because Q3 is negative, and it will be directed to the right. For the simplicity, we can show x-axis here, and now we can calculate F1. In a vector form, F1 is a sum of F21 and F31. Now we have to apply the Coulomb law to calculate the forces. F21 equals absolute value of F21 equals to K multiplied by Q1 multiplied by Q2 divided by L square. And we are taking an absolute value in order not to confuse with the signs. Meanwhile, F31, absolute value of F31 equals to absolute of K Q1 multiplied by Q3 divided by 2L all squared, which is absolute of K Q1 Q3 divided by 4L squared. So the distance between Q1 and Q3 is 2L. That's why it's the fraction, the force is divided by 4A squared. So now we're gonna calculate the force. So F1 equals to absolute value of F31 minus absolute value of F21. So by taking absolute values and placing a negative sign between F21, we overcome possible error with the sign, and now our answer will be correct. So in other words, absolute value of K Q1 Q3 divided by 4L square negative K multiplied by Q1 multiplied by Q2 divided by L square equals to K Q1 divided by L square. So Q1 is positive. That's why we can leave the brackets, the absolute brackets out. Multiply by absolute of Q3 divided by 4 minus divided by 4 multiply minus Q2. Now let's complete the calculation. F1 equals to 9 multiplied by 10 powered by 9 Newton meter square Coulomb square multiplied by 65 multiplied by 10 to the minus 6 coulombs, because we have to convert microcoulombs to coulombs, multiplied by 1 over 0.4 square meter square. Again, we have to convert centimeters to meters. And it's multiplied by 95 10 to the minus 6 coulombs over 4 minus 48 10 to multiply by 10 to the minus 6 coulombs. And if we do the math, it equals to negative 88.7 newtons. So the negative sign means that the final force will be directed to the left because F21 is larger than F31. Now let's calculate F2. The force which is created by the electric field on the central atom, Q2. Let's look at the scheme. So Q1 and Q2 undergo repulsion. That's why this force will be F12 is directed to the left, to the right, is directed to the right, because this is the force of repulsion between the first and the second charges. Meanwhile, Q2 and Q3 undergo attraction, and F32 is directed to the right as well. Now, let's calculate F2. Again, in the vector form, F2 is the sum of F12 and F32, but in a scalar form, F2 equals to absolute F12 plus absolute value of F32. So it's important to understand that due to the fact that F12 and F32 are heading to the same direction, we have to take a sum of two absolute values. As in the previous task, F12 equals to K Q1 Q2 divided by L square, and F32, the absolute value, equals to K multiplied by Q2 multiplied by Q3 divided by L square. So here the distance between all the charges is L, that's why it's pretty straightforward. Now we can complete the calculation. So F2 equals to K Q2 divided by L square multiplied by the sum of Q1 and Q3, which is 9 multiplied by 10 power by 9 Newton meter squared divided by Coulomb squared multiplied by Q2, which is 48 Coulomb divided by 0.4 square meter square, and it's all multiplied by the sum of 48, 65, and 95. 65. And if we complete the calculation, we'll get that F2 equals to 432 newtons, which means that F2 is directed to the right.